Alright, so we're going to look at the periodic table. This is the periodic table similar to the ones that you have. And so we're going to go through and look at some of the properties of the periodic table, and then we'll look at how the periodic table kind of was brought together. And then we're going to use the periodic table to look at average atomic masses at the end of this lecture. So on the periodic table you have three different types of materials. You have your metals that are highlighted yellow here, so it's going to be all of these guys. And then these guys as well are also metals. Notice that they fit right into in between here. So this is number 57, so this is number 58, and so really this whole lanthanide and actinide series here is just fits inside this space. And so when you're thinking about moving through the periodic table, increasing the atomic number, you have to go from 57 to 58. You can't go from 57 to 72. And so then you have your nonmetals. And so nonmetals are going to include hydrogen, and then everything over here on the right side. These are your nonmetals. And then we have your metalloids. So metalloids are along this zigzag line, excluding aluminum. And if you don't have the zigzag line in your periodic table, you just need to know where it starts, and it just goes down like a stair step. And so if it starts under boron and aluminum, it just is going to go down, over and down until you get to the bottom. You can make it go all the way down, that's fine, but we really stop at polonium, but it's fine to go all the way down. You're not going to be using these elements down here anyway. And so next there is a link in the slides for a video, and this video is of Dmitri Mendeleev. And so if you click on the link in the slides, I highly recommend watching this video. I don't think it's going to let us have the sound on while I'm talking. It may be currently on right now. So I'm not going to have the video play during the lecture, but I would recommend that you watch this. It's really interesting, and Mendeleev is really cool, and he came up with a lot of the stuff on the periodic table in the 1800s, and we are like in the I think in like the 1900s and the 1960s, we're discovering some of these things that he predicted, and so it's just interesting. Definitely click on the link in here, or go just periodic table TED Ed is going to be what you would Google to find this presentation, and watch that video. It's really interesting. So let's talk a little bit about metals. So metals are on the left side of the periodic table, and I don't say the middle of the periodic table because we kind of differentiate the periodic table as left and right side on the basis of that stair step. So you'll say left side of the periodic table if you're asked a multiple choice question about this. And then the metals are going to have specific properties. And so metals do conduct electricity, and they conduct heat. They're usually shiny. We can also use the word lustrous. Don't know if I'm spelling that right. They are ductile. That means they can be pulled into a wire. And they are malleable. That means they can be hammered into a sheet. And so when you're thinking about a metal, they should have all of these properties, and so that's why we call aluminum a metal instead of a metalloid, because it has all of those properties. Nonmetals are kind of the opposite of metals. So just think about whatever a metal is, nonmetals are the opposite. So they don't conduct electricity, they are not shiny, they're not able to be hammered, they're really brittle if you were to hammer them and break. So for metals, it's easy to think about aluminum That's a metal that we all come into contact with pretty often. Or like iron. Those are like metals that are pretty common, and so thinking about those is better as your like examples. For nonmetals, a really good example would be like carbon, like the graphite in your pencil is pure carbon. And so like if you were to like hammer that, it would just shatter, right? You couldn't pull it into a wire. You couldn't hammer it into a flat plate. It would just kind of shatter if you were to press down too hard on the graphite of your pencil. And so this is kind of like just a multiple choice type question, like properties of metals and nonmetals. It's not going to be like a short answer type question, but you should be able to identify an element as a metal or nonmetal based on its place in the periodic table. So like if I say like, what is scandium, you would say metal, because scandium is on the left side of the periodic table, hanging out right over here. And then you have your metalloids, which they have properties of both. So some textbooks have metalloids labeled differently. I just say everything along the line except aluminum, you'll be good to go. For your metalloids, the big one to know is silicon. So that's what your computer chips are made out of. They have different properties, but they have kind of a mixed bag of properties. And so you can't really tell exactly the properties of a metalloid, but you may be told about them in a question and asked to kind of think about it. So groups of families you need to know. You need to know the alkali metals, they're group number 1. You need to know the alkaline earth metals, they're group number 2. Then you need to know the halogens, group number 7, this 7A or 17, depending on how your periodic table is labeled. And then you have the noble gases, group number 8 or 18. You need to know the names of these groups. I would also know that the middle of the periodic table are called the transition metals, and so here you have this group, the transition metals. You also need to know common ions, and so if everybody in group 1 right here has a +1 charge, group 2 has a +2 charge. Not naturally, this is when they form an ion. So when they lose or gain electrons, they have these charges commonly. If I just say lithium and I don't say lithium ion, you're going to assume neutral. So just a quick note, always assume neutral unless you're told otherwise. Unless you're told ion, or if you're told number of electrons, you can tell if it's an ion or not because it has a different number of electrons or protons. But don't just assume that it is an ion out of nowhere. If I just say like aluminum, I don't mean aluminum +3, I mean just normal aluminum. Transition metals have cations, so cations are positive ions with various charges. And so there are a few that have the same charge, and so I'm going to go ahead and show you those here. They're not in the chart. So you want to know aluminum and gallium. You can know indium if you want the one down, but mainly I'm just going to kind of focus you on a few that you for sure need to know. Aluminum, gallium. Zinc is always 2+, and cadmium are always 2+, and silver is always +1. So these right here are always the same charge, and so I want you to know the ones I've kind of highlighted over here, outlined in black. You need to know that your 7, your halogens, are -1, the oxygen family is -2, and then the nitrogen family is -3. And so you kind of go positive to the right and then start at the left and go negative. Your nonmetals are typically going to form anions, negative ions. Your metals are typically going to form positive ions or cations. Noble gases have a charge of 0 because they don't interact with anything, so they don't lose or gain any electrons. We'll talk about that more when we talk more about electrons later. And so we talked a little bit about isotopes in class, but an isotope is essentially the same number of protons, so the same identity, but different neutrons. And if it has different neutrons, it has a different mass. And so here is a sample of neon. A sample of neon is 90% neon 20, 9% neon 22, and 0.27% neon 21. So the most abundant is the one with the highest percentage. So the most abundant one is neon with a mass of 20. And so if you look at the periodic table with the mass of neon, we'll just kind of scroll back. Neon has an average mass. Oh wait, this one doesn't have masses. Whoops. Neon has an average mass close to 20 if you look at your periodic table, because it has 20 as the most abundant. And that makes sense. So like your most abundant isotope is going to be the one that's closest to the average mass, right? But just because it's on the periodic table as an average mass doesn't mean that every atom has that. So just because neon says 20 on the periodic table doesn't mean that every neon is 20. Some neons are 21 and some neons are 22, and that's fine. Now we can use these percentages and these masses to calculate the average atomic mass, which we're going to do in a second. Here's that isotope notation I showed you in class. So you have the mass number on top, the atomic number on the bottom, and then the symbol. You can also add the charge in the top right if you want a charge. If you don't have a charge, you just leave it as blank. Just to recall, for mass number, you're going to say protons plus neutrons. Atomic number is protons, and charge is protons minus electrons if you're calculating these things mathematically. So average atomic mass is a math that some of my classes are going to do, some of my classes are not going to do. If you're Chem 10, you're going to do this. If you're Chem 2A, you're not going to be doing this. So for average atomic mass, you need to take the percentage, okay, turn it into a decimal, okay, by dividing by 100. And then you multiply it by its corresponding mass. And then that's going to be a pair. And then you're going to add those pairs up to get the total weighted average. So this is not just an average of adding up all the masses and dividing by a certain number. It is a weighted average. And so we need to think about it in a percentage-wise. And so just like your grades might be a weighted average, your quizzes don't count the same as your exams. And so you can't put your quiz average and have it be the same amount as your exam average and like do a normal average with it. So you have to look at your percentage. So we change the percentage to a decimal. An easy way to do this is to pop the decimal back 2 places or divide by 100. And so I'll often write as a general form decimal percent divided by 100 and then times the mass plus the percent divided by 100 times the mass plus keep going, right? That's kind of a generic formula for average atomic mass, and this is going to be your average. Remember, this is a weighted average. And so here I'm taking the 75%, 0.75, and then multiplying it by the mass. Don't multiply it by this mass number if they give you a more precise, more sig figs. Use the one with higher sig figs in your math. And then you're pairing together the 24 at 0.24 with the 36 and the 36. And you do this math out, you get 35.45 AMU. If I tell you it's chlorine, you can check your work. So look at the periodic table for chlorine, its average mass is 35.45. So if you're checking your work here, it's kind of easy to make sure you get the right work because your average mass should match the periodic table of a specific element. But what if I give you information like this? What is the percent abundance of each isotope? And you may have a homework question that's asking you about this. And so we're going to dig in a little deeper with this question. So we need to go and find the percent, the average atomic mass of neon. I don't know it off the top of my head. I think it's just 20. Neon average atomic mass. 20.197. So we're just going to write this down. The average mass is 20.1797 AMU. Okay. Now, you're not going to use these numbers. This is the name of the isotope. So the mass number always comes after the name when you're writing this notation. But we're going to be using these numbers here. So they want to know what percentage goes here. There are only 2 isotopes. So I know the percentages must add up to 100, right? And so when we're doing this math, remember that I divided my percentages by 100. So what's 100 divided by 100? 1. So my decimals, percentages must add up to 100, therefore decimals must add to 1. So you can do your percentages out of 100 or you can do them out of 1. I prefer to do them out of 1 because we don't like using percentages in math. So let's set up our equation. So we have average mass is equal to your percent divided by 100 times your first mass, let's just say mass 1, plus your percent divided by 100 times your mass 2, and we only have 2 of them, so that's what it's going to be. So now let's plug in some things. So my average mass is 20.1797. Now my first percent, I don't know what that is, so I'm going to just say X. My first mass is 19.99. And then my second percent can't be Y. It also can't be X. But X and then this have to add up to 1. And so I'm going to say 1 minus X here. Because if one of them is X, the other must be whatever is the difference between it and 1, so that they add up to 1 in the end. This is going to be your format for this. This is kind of your hardest level question with average atomic mass. And then that mass that goes with that is 21.99. And so now we could just go through and complete the algebra for this. I don't have my calculator on me, so I'll be doing some calculations via Google. You can see that super high technology while I'm working through that. And so let's just kind of move all this stuff around, make it a little cleaner. And so I have 19.99x plus, now we have to distribute. So this 21 is going to get distributed to the 1 and also to the x. So I have 21.99, and then this is negative, minus 21.99x. Now we can combine like terms, so 1999 plus 2199 equals 1999 plus 2199, 41, so let's say 20.1797 is equal to 41.98x. Oh, I added them. Whoops. I should be subtracting them. So subtracting them, sorry, is negative 2. And then for sig figs, if I look at my sig figs here, I have 2 digits after the decimal, 2 digits after the decimal, so I need 2 digits after the decimal because I'm doing addition and subtraction here. And so I'm going to keep 2.00 here. Plus 21.99. So I'll just combine the x terms. 1999 minus 2199 is negative 2.00. And now I can, oops, that should be x. And now I can combine the rest of this. Let's subtract both sides by 21.99. I'm going to have to cut off here for sig figs, so make sure you watch that. 20.1797. So 20.1797 minus 21.99 is negative 1.8103, but I'm only going to keep these numbers here. So I get, I'm running out of space. Sorry, I'm only going to keep these numbers here. So when I'm doing this math, I'm only going to keep the numbers after the 9 because that's my sig fig rule for addition and subtraction. And so let's do negative 1.8103 with only these numbers kept equals negative 2.00x with these numbers kept. So therefore x is equal to negative 1.8103 negative 1.803 divided by negative 2. And so my x is 0.9015. So I'm not done yet because that's my x. And so what is my percentage version of that? So to get out of the percent, we divide it by 100. So now let's multiply this by 100. So my percent for x, which I assigned here with the 19, the percentage is 90 point, and I can only keep 3 sig figs, right? So 90.2%. So what is my other percent? Well, it's whatever 100 minus 90.2 is. And so my other percent is going to be 9.8%. It's okay to have 2 sig figs here because it was a subtraction. I'm looking at the digits after the decimal place. So that's the answer to this question. Definitely pause, go back to it, try to work it out if you can, but also know that this is a very difficult question. Kind of that Chem 11 or higher level question here. All right, thank you so much.